everyone. It's been a while since we did it. So, as you said, I apologize when we started for the talk name. We said we were going to do 2,500. When I actually logged in to do the demo, we're at over 3,000 today. So, a little bit about booking. This is a requirement for any of us to give talks. We got to do the corporate spiel. For those that are not familiar, Booking is one of the world's largest travel website. We use technology to enable people to travel the world. I was reached out about 4 years ago this month by Booking. As you can tell, I'm originally from the United States. I live here in Amsterdam. And they were like, hey, do you want to come here, help us be a travel website? I was doing a bunch of startups. I looked at the different companies that I was considering going to at the time. I figured, travel on the scale of evil to not evil, more on the scale to not evil. So I decided to join Booking and to help people do something that I really enjoy, which is travel the world. We use the different teams that I work with. We have about 3,000 plus developers, as was noted before, and we build lots and lots of different tooling for people to book websites, hotels, and also flights, attractions such as book tickets, and to do all the fun stuff. So to the meat of the talk, which all of you are more interested in. What we're covering today, we have various topics that we need to cover, which is we need to enable developers to be able to control their development environment, interact with the legacy system that has existed for over 15 years, has made billions of dollars per year, not break those systems, and to move forward with. So high level, how do we do this? I think a lot of you have seen various other talks where people compose various Terraform modules. They also, when we use Terraform and Terraform Enterprise, one of the key things we have to work about is how do we place things into workspaces, and how do we split them up? How do we split up those various workspaces as an organizations? And I'm going to hand wave over. There's other talks here that go into much more detail of how we solve these various problems, but we do use and we do create virtual machines via images, via Packer, via image pipelines. Not overly shocking to people. That's done. It's a very common pattern. But that was a key thing that we were able to do to make this work. And the other thing that we did to accelerate replacing these legacy systems and to do it as quickly as possible, the key thing besides Terraform, that was the code that we did. But to orchestrate, get everything together, make it so that we don't have to do a lot of mundane tasks and we can go to market faster, we use Terraform Enterprise. So what's the big deal? What are we working on? Like how is this doing? As we mentioned, we have 3,000 various users. I did name them as developers. It's roughly 2,000 developers directly, 1,000 data scientists, and 1,000 designers that use the platform that we control, that we use and enable people to do their day-to-day job. So when you have 3,000 different users that are also your coworkers, and the system breaks, and they can all reach you on Slack, your life kind of sucks when things break. And so this is the reality of the system that we had in the legacy. It was consistently, well, consistent is the right word. It was constantly breaking and consistently breaking. And so we had to replace it. And we also, one of the things that we wanted to do is we had 2 different applications that were owned by 50 different teams. So we had this organizational problem of what happens when the virtual machine infrastructure breaks. The application code that they run may break on those individual machines, and those 200 different applications that 3,000 different people may launch have to go talk to 50 different teams. And one of the ways that we solve that, and I said we're going to hand wave briefly over it, is we set up an image pipeline. We allowed the 2 different applications to be able to create it in a factory, and we allowed users, we pointed them instead of the infra team, which I'm part of, we pointed them to the people who actually own the code that would break. Because they say, hey, look, we're just responsible for the provisioning, the automation, and everything behind it. But if your actually application code breaks, that's something that's outside of, we may be smart, we may be good at the infra side. We're not writing the actual website code. Please go work with those teams. And we allowed and we pointed people to the various teams. So that actually helped us scale quite a bit. And the other thing that we found out working with different users and different pools, for an average developer in Booking, they may work where we have the different websites. they may spend up to do your job. It's not spinning up one single machine to do your application. This is a lot of different legacy code. They would have to spin up 3, 4, 5, 6, 7 different machines, have them talk together and interact with each other to be able to test out their different interactions. So they'd have application 1, which could be the main website, and they may have an order system that they have to schedule. Maybe they're doing some Docker containers more advanced, so they have to have a Docker VM, and so on and so forth. So we'd find out that when people, instead of spinning up a single VM, they'd have to spin up 5 and 10 in groups of them. More towards the legacy system. It served its purpose for the time that it was up. I didn't know what OpenNebula was, but it's just basically, it's a smaller scale. Think of precursor or similar to like an OpenStack type system, but with smaller pieces. It was based in Ruby, it just happened to be Ruby. The scaling issues, there was also other architectural issues. We did replace it with OpenStack, which we'll go into in a minute. And the other big issue that I referred to earlier is there's a lot of confusing ownership issues. And this is a big piece. And so one of the things that we wanted to be able to solve was you own your machines that you spin up. If the machine you spin up, it doesn't break from if I spin it up, it has an IP address, it boots, you can log into it, not my problem. We want to be able to point you back to the other people that once it comes up, that their piece that broke. And I know this is kind of sounding like pushing, maybe not helping our colleagues as best as we can, but the reality is the best way we can help our colleagues in the situation is point them to the people who can actually fix the problem, not ourselves. So if you're like, oh, maybe this dependency broke or something else, please go talk to this other team. And what we wanted to do as part of when we built this was to remove ourselves from that loop. Instead of them to come to us and say, this is broken, and we redirect, we could just directly connect everybody. And that's one of the key things that we did. So we have a new system. Sorry, I'm not a graphics designer. I barely can code at days. And so this is happy developer she's super happy. We wanted to be able to do two things for two different users. I'm not going to go through the UI today, mainly because it's very, very booking specific and not that interesting. We have a backend service that creates VMs as a service. It actually creates Terraform code, which I'm going to go through in a second. It commits to a Git repository. The human developer, if she chooses to, she can go to the Git repository or use the UI. 99.9% or 99.3% use the UI. There's a few of us, me included. We'll skip, I actually use the UI for a lot. For advanced use cases, I go to the Git repo, which we'll go through in a second. And then it commits to the Git repo and goes to Terraform Enteprise. And then it goes and provisions the various machines on OpenStack. I know, OpenStack, I know, I hand-waved over some other stuff. There's a lot of legacy involved. But in order to do this with a very small team, we had about 5 to 6 people working on the code. It's being generous, probably about 3 to 4 consistently. And we had to make all of this stuff work for the 3,000 people across the 200 different teams with very limited interaction from them because, their job isn't to help build development machines. Their job is to go help booking make billions of dollars, doing hotel rooms and flights and so on. So we had to do this in a very constrained environment. So I'll walk through a quick demo of what it looks like spinning up. I think you've seen this similar before and how it kicks off. Oh, this is the payoff, and I'll walk through how we get to this in a minute. But this is kicking off, go into the UI. I clicked a button that said create a virtual machine. We're kicking off our plan. It's doing the exciting, really fun part about building your virtual machine. You'll notice here, you'll see some stuff that may be a little unusual. We actually had to write some custom providers with Longinus, which I'll point out in a minute. This is the cool part as well. Some of our legacy that we often broke code and we made mistakes on. We wrote Sentinel policies, we used Puppet, to be like, did you set your metadata correctly? Because we wanted people that were more advanced, when they forget to set metadata, which we all do, we wanted to make it before their machine spun up and they called us that it was broken. We just checked to be like, did you remember to do this? Relatively simple. The other piece that we did, 95% of this is standard. We just used the provided HashiCorp providers. We have some custom DNS tooling internally. That's a Longinus provider, just some REST API calls. That's all it is, and it creates up some custom REST call. That's creating a virtual machine. Not super exciting, maybe for you. Super exciting for us, because this is actually played in real time through the system, interaction through clicking buttons. The provisioning of the machine is under 30 seconds, going through Terraform, going through our entire system, and we can actually log in about 30 seconds. The previous system used to take 45 minutes. So as we go through, the other common thing, well, we bug developers constantly. You have to delete a virtual machine. You have to go do the reverse, do the dependency deletes. Most people will spin them through VM. They'll leave it up for months. And then we have to nag them and email, hey, security says you have to delete your stuff after 30 days. They'll get an email. They'll go through and delete. They interact through the UI. They click a button, and it goes through, and it deals with deleting the virtual machine and all of its other dependencies. We also have some custom code involved that do a little bit more advanced, a lot more advanced things, such as we may have firewall rules that need to be created, interact with our other things we had to do, and we just kind of do this for the users, because we have 2,500 different people. They may not know that that particular role or particular application needs to have firewall rules. It would be broken. They would end up having to call various people to figure out why it was broken, and we made it so that it happened as part of this interaction. We actually give back to the user if a firewall rule apply failed, or we actually put their virtual machine in an error state, and then we'll allow it so that they can recreate it on the fly, so that they don't get into a half-broken state, so that they can self-service as much as possible. So as I alluded, we do have a UI. That's the more advanced topic, or that's the more general use case. The more advanced use case that many of us do is we interact through the CLI, and we modify the code on the fly. I'm just going to go through and show the demo I just did, where we did the create, delete. One of the things that we learned when we were doing this system is you know what you know, and you don't know what you don't know. And as we were going through this, and we were creating these different iterations, we had to constantly modify the code, which I'm going to go through and show you, click through. Let's go take a look at one of our machines, or one of our code that we have that modifies a machine. It uses a module. It has a bunch of custom variables that we set for that individual thing that just says, this is the type of machine, this is type of VM, which then fires off, goes to the module. The more interesting piece that we do, and this is one of the more interesting things we did, is when we go through and we have automation, we want to allow users to be able to modify their code. And we also want to be able to have our code to be smart enough, because we make mistakes, to go through and auto-update the modules for the users. So we added, you saw briefly, there's a serialization header. We just said, oh, our automation did it. We compare it. If it's the same as our serialization header said, we will modify the file for the person. If the user went in and more advanced and modified it, it's on you. We're not going to touch it. We're not breaking your stuff. So that's one of the more things we did. It was kind of a geeky, fun thing we did. Also, you can see here, we're just going through deleting, going through the UI. You can look at the history. You can see the other pieces that we did. And as an all demo, fun stuff that we did, I apologize I couldn't do this live. It's more on the Wi-Fi. I did a few typos as we go through as well. But you can see in the back end via the API, we can see a full history of what our service is doing in the background. It's generating files. It's doing code merges. This is just through typical Python GetApps libraries. It's not overly magical. The other thing I just went through, and just to show, as I alluded to, we also very, very commonly create groups of machines. I created, 4 machines and a couple DNS entries as well. We're going to go through, take a look. I created the 4 machines. Very common thing to do. I personally don't like clicking 10, 15, 20 buttons to delete stuff. So I just log into my repo, which I'll do in a second. And I'm going to go through and just do an rm star Terraform. So I'm going to go through, just walking through. You can see that the code did it. and this is where it goes. The other advanced topic, there's so much that you can do through a UI. And so those of us that have written UI, and to do, maybe there's 20, 30 different use cases that you can enable. Somebody says, I want to have a very specific DNS entry to be able to do this very specific thing. And it's like one user. Well, this is this is the reason that we allowed people to have access to the repo, is because we've had a couple different high-value use cases for regulatory reasons where we had to have regulators come in and test things independently. We'd either spend, it would take us like 6 to 8 weeks or maybe longer to do it in the UI for that use case. We were able to just take and modify a couple of the Terraform files here manually. We were able to just update and create the records via Terraform file, commit it to the repo and do it. It took about 5 minutes. And so it's either, let's go through and do it. And this is where we talk about advanced users. It did take us like 2 hours to train people to do it, for the 10 people who had to do it, and then they were able to do this on their own. Then we walk away. Those come up occasionally. Just bring it up that sometimes trusting your users a little bit more and then giving them access to the stuff under the hood does pay off. As you can see, this is just walking through the different screen that we're doing here. I'm deleting it as a user. The other thing that I wanted to do, because as a new user, I want to say, I'm going to do these different changes. I want to take a quick look, and I'm going to do it from the CLI and do it very quickly as I'm iterating through my development plan, see what it's actually going to do. Big shocker, because I deleted the infra. The Terraform file is actually going to delete it. It becomes interesting and a little scary for people when they first start to do and they do changes. This gives them the ability to be able to do modifications in their own workspace. It allows them to practice doing things independently before they do things in their scarier production workspaces as well. So this is one of the things, you can do things safely, you can go through, and you can check things as well. And so after I tested it, I know it's going to delete. I go ahead and push and delete my actual files. That is the payoff. I can spin up the VMs, the virtual machines. That's the particular thing that we're trying to enable. But how do you actually enable those 3,000 plus people to be able to do this through the UI? That's actually the harder part. Well, besides doing all the legacy code interaction and making that all work, that was actually really hard. But how do we spin up these 3,000 workspaces, 3,000 Terraform workspaces with 3,000 GitLab repos, interconnect all of the OpenStack projects for the users, and how do we glue that all together? That sounds hard, kind of hard, not really. It's just a big for loop. Couple for loops. And so what we do is we go to the source of truth. Who are the users? We have a staff API inside of Booking. That's where we start to. That's where we go to. So we go to the staff list. We figure out who has access, what team are they a part of, grant them access, and we're going to create the infra. We have to create the GitLab repository. For that user, we go to the Terraform Enterprise. And then actually Terraform Enterprise, in that workspace, that bootstraps our OpenStack projects, gives them access to the code. We actually, Terraform Enterprise, inside of that workspace, we use the Terraform Enterprise provider, or cloud provider, big shocker there, and we bootstrap all of the dependent workspaces from there. So we'll go through a workspace creation demo. As I said, this runs in a loop. In this particular thing, this just runs all the time. So let's go a little back. Let's do it a little bit in reverse order. What I'm going to do is I'm going to log into this dev R08. That's actually a team. There's 3 reasons we do smaller teams, but that's the name. As part of that, when we go into the workspace, we have all of these different variables that are associated. That's all of our internal. That's an implementation detail of how we do it. I can go through, look at the history of all the runs, see what happened. You can see fairly common for continuity. We actually do capacity testing against our various systems. I want to go take at this particular merge. I want to go figure out what's going on. I take a look at the code. I see a bunch of changes were made. Looks like a bunch of additions. I can look at this very quickly and understand what it was, but I'm going to take a step back and take advantage and go look at the commit that did this, our automation to debug it. So I want to see what happened. So I click in, I go to the commit. Now I'm into GitLab. I'm going to go look at the repo. and we see our user. Yep, we added a user. We added a user, and it triggered all of those changes that we happened in the run. OK, let's take a step back. Let's go take a look at the actual code that gets triggered when this happens. So I'm going to go take a look at our repo. One of the things that we learned is we have a versions Terraform file, versions of all the providers we have. We do this centrally, and we do this in every repo. We follow the best practices, and we go from there. Something else that we learned as well, we have multiple clouds on the back end. And so this is our provider configuration, which we point to London, Amsterdam, and Frankfurt. These point, if you looked, it's an implementation detail as well, but there's a clouds YAML. It points to, and I'm just pointing this out, this is how we say we do more than one cloud, is we just point an alias and we go through. Let's go take a look at the workspace. So we have, these are it's just a set, it's a local. These are all the users and the usernames here. We go through, and this is, we look up some different resources. This is OpenStack project, same as an AWS account. It does a whole bunch of settings that sets things based on the user. Much more interesting to me is the dev workspaces. We also have a module, all at Bootstrap. Bootstrap's a workspace that we link for every single user. We first do the GitLab repo, we do the workspace, we put our variables that change it all together so we can actually spin up our virtual machines. We take all of our secrets that get generated here, we propagate them to the workspaces. We do this all in one central location so that when we have to go through and rotate passwords, I can do it in a single thing. I don't have to log in, it just propagates. There's not a lot of work. Let's go look at a workspace really quickly. This is mine. And you can see I kicked off earlier, remove all VMs. This is one of the things that I kicked off from the CLI that I did before. We have various variables that we propagate that are booking specific that we kick off. We also have some secrets, our firewall user and password that we do to do some orchestration so that I can actually work and do my various code. And also, one of the things that we often do, and we in our code, we update it in a single template. It'll update the master 100 workspaces, then propagate to the 3,000 workspaces when we update Terraform. So we can update it in a central location. We update a module. It runs some for loops, reads through our code, obviously after we test it, and then updates everything at once. This is critical of like, how do you do compliance? How do you do it centrally? How do you scale so that we don't log into 3,000 workspaces and have to do it all manually? And this is how it's all tricked. And then, as you can see, I have a repo. This is what, on the CLI, you saw me interacting with before as well. So this is more of like, this is what's possible. This is how you can scale, because very, very early in the days that we were working on the system, a lot of people would be like, Terraform doesn't scale. Terraform Enterprise doesn't scale. This doesn't work. Well, we're doing it with 3,000. This is for one use case. We have about 10 other use cases where you have, I don't know the exact workspace count. It's in the tens. It's not a lot. And this is what we're doing. So it's possible. So what did we do? And by the way, we did this all during the pandemic. Holy shit, that was hard. All remote, data center stuff, broken, we couldn't get in. We had to build the cloud, trying to talk to everybody over Zoom. We hired new people, never met them. That was hard. But what was achieved? Via new tooling and processes and system improvements, we went from under 45 minutes to spin up a virtual machine. Not necessarily because of Terraform, but because of the other things we did, using Packer, creating, pre-baking the VMs, using the new, better architected systems, we were under 5 minutes. We got a lot of kudos from our users. I'm not going to say it's quality of life changing if you're a user that has to wait 45 minutes for something and it takes 5 minutes. You don't click a button, wait for an email, go get a coffee, come back, forget what you're doing the next day, and then go use it. You can click the button and then actually log in a few seconds, 30 seconds later, and have it usable in under 5. Another thing that we did via our factory approach, we did 100 applications, 3,000 users. From start to finish of the first application, it took us about 3 months. A lot of planning, a lot of automation. We made a bunch of mistakes, but because we had these things in place where we could upgrade as we went, we could change and modify as when we started, we were able to move incredibly quickly. As I said, we do mass updates from a central location. We upgrade Terraform code to new modules, more software engineering best practices by doing forward compatibility. Hopefully, if you go through some of the other best practices or you look at forward compatibility is a big, big thing. You have to design it in, think ahead, and you can do these type of approaches using those techniques. Thanks, everyone.